Good morning, everyone. My name's Aman, and welcome to this GCSE Chemistry online school session. So today we're looking at the introduction to electrolysis. As promised, we'll start with a few exam questions from natural polymers from yesterday first, and then we'll go into electrolysis. We have a couple of lessons on this, so one today and one next week as well, because it's quite a difficult topic. If you don't already know me, my name's Aman, and I've taught all the online chemistry lessons, and we've done a range of topics. Today's session will last for 1 hour, so from 9:45 until 10:45. And as usual, if you have any questions at all, please pop them into the chat box or the Q&A, and I'll pick them up as I'm going along. If you don't already know me, I study medicine at King's College, and I've done plenty of lessons with my tutor. So let's get started. So the learning objectives for today are to know what occurs during electrolysis, so specifically to do with the equipment that we use and how electrolysis works. We need to understand and explain the difference between the products at each electrode in an aqueous versus a molten electrolyte, which we'll go into a lot more detail with. And then the higher tier is to be able to write half equations for what occurs at each electrode. We may not get onto this today, but we'll see how we get along. So we'll start with some exam questions from yesterday's topic. So hopefully on the screen, not this one, sorry, this now. So we've got starch. It's a complex carbohydrate, and it's a natural macromolecule or polymer. It can be formed from its monomer by condensation polymerization. So does anyone remember what's the monomer of starch, and how can we explain what monomer means? Any ideas? So what's the monomer of starch, and how can we explain what monomer means? Good, yep, so the monomer is glucose, excellent. So the mark for this question is about explaining what monomer means. So it's good that we all remember what a monomer is. What the monomer is, but what does it mean? How can we kind of come up with a universal definition for monomer? Does anyone have any ideas? So we've come across loads and loads of monomers this week for both natural and synthetic polymers. Any ideas what monomer means? Good, yeah, so it is the repeating unit. It's a single repeating unit. So in this specific question, they're kind of looking for two things. So they're looking for the repeating unit that comes together to form a polymer. So excellent definitions, well done. The second question is to explain the term condensation polymerization. So what do we think? What's condensation polymerization? Condensation polymerization. So we've learned about two types of polymerization this week. We've learned about addition and condensation. Okay, so a few kind of mixed definitions. I've not had a correct definition yet. Okay, all right, so we've had one. So it said lots of monomers join together via covalent bonds to form a polymer and a small molecule such as water. All right, that's a good definition. So I'll type these out for you. So a monomer is the repeating unit of a polymer, or the repeating unit used in making a polymer. A condensation polymerization, the definition for that is, as most of you have said, so first of all, I would say breaking the double covalent bond. So remember, with polymerization, we break the double covalent bond between the carbon atoms to allow for the monomers to join up. So breaking the double covalent bond to allow the joining of monomers to form a polymer, and as someone said, a small molecule. Don't forget, it's not always water. It can be hydrogen chloride, so such as water or HCl, hydrogen chloride. It's not hydrochloric acid, it's hydrogen chloride there, so usually as a gas. Good, any questions about that? I've had lots of good definitions there. So where molecules join together, losing small molecules. Are we doing lots of exam questions today? So we're going to start with exam questions just from yesterday's topics. I know we struggled a bit yesterday trying to do exam questions, and then we'll go on to electrolysis, and then the bulk of exam questions for electrolysis we'll do next week when we do our next electrolysis session. Okay, so draw the structural formula of starch to include 3 monomer units. So glucose, the monomer, can be represented as this. So this is quite a difficult question. We need to draw 3 monomers coming together to form the polymer starch. And they've shown us how to represent glucose. So you may remember yesterday, I showed you this box that we like to use so we don't have to draw out all the carbon molecules. So any ideas what they might be looking for when we draw out starch, or what's going to change when I try and draw that out? Any ideas? Okay, so when we join these together, we're not just going to draw out 3 different monomers. Yep, so someone said an O bond, good. So does anyone remember what that O bond is called? So you're right, there is an O bond there. What's it called? And someone said square brackets, excellent. Someone's given me a really good kind of written down version of what it will look like. I'm going to draw it in just a second. It's not called glycogenic, it's not an amino bond. What's it called? Glyco, kind of. It starts with glyco. Does anyone remember? Not amo, good, not amino or amide, it's glycosidic. Yeah, excellent, glycosidic. So glycosidic bonds between glucose molecules. So if we have a go, then we'll have our OH, square box, O, and then it's going to join to another one, square box, O. And remember there are 3 monomers and you don't want any more than 3. So this is our first one. This is the second, and this is the third. So on the end, you will have your OH, like so. So remember, when you join 3 monomers together, you will have 2 glycosidic linkages, and the glycosidic linkages are these O bonds here. So it will look like that. Excellent, well done, everyone that gave me an answer to that question. Okay, we're not doing that one there. All right, so draw the structural formula of the addition polymer formed by the polymerization of phenylethene. So does anyone remember then? So this is addition polymerization first of all. So remember that means only the polymer is formed. What will it look like? How do we draw it? What do I need to remember to do when I'm drawing out the addition polymer for that? Does anyone remember? Good, so we need to break that double bond. Excellent. So I'll break that double bond then. So if I draw it out, got C, I've broken that double bond. We've got C6, H5, H, and H. Okay, what else do I need to do? 2 more things. Any ideas? So I've broken the double bond. Good. You need a bracket. We need square brackets. That'll give me the second thing. And there's one final thing I need to do. So there's my square brackets then. What's the final thing? When we're drawing addition polymerization, there's 3 things that you need to do. Okay, all right, 4 things then. So someone said put an N in the bottom corner. Yep, we need the N in the bottom corner. So you wouldn't have got the mark in this exam board for doing that. But yeah, AQA want you to put an N. So yeah, the final thing, as someone's just told me, is to put these lines through the square brackets to show that it's a continuation. And remember, carbon always forms 4 bonds. So we need to draw that 4th bond in because we've broken that double bond. Excellent, well done everyone. Okay, nylon is made by condensation polymerization. It has the structural formula shown below. Name the linkage in this polymer. So this is the linkage here, C double bond O NH. Does anyone remember what that bond is called? It's not amide, but you're on the right lines. Not amino, nope. Any ideas? So C double bond O NH, peptide, excellent, well done. It's a peptide bond. So specifically this bond here is the peptide bond. So we call that a peptide linkage or peptide bond. Name the natural macromolecules which have the same linkage. So does anyone remember what natural molecule is formed from peptide bonds? So remember, starch and cellulose are the natural molecules for glucose. What's the kind of natural molecule or macromolecule made of peptide bonds? Good, protein. Yep, protein. Excellent. So proteins are the natural molecules made with the same linkage. Okay. Slightly more tricky question. Deduce the formulae of the 2 monomers which reacted to form the nylon and water. So we need to look at this and find out what the 2 monomers are. So any ideas how we go about doing that? So remember, nylon is formed from a dicarboxylic acid and a diamide. And we can see that there because we've got the NHs and we've got the C double bond Os. So what are the formulae? Does anyone know? Good. So dicarboxylic acid and diamide are the monomers, but we need to know the formulae of them. Someone's asking, is chemistry much harder at A level than GCSE? If you enjoy it at GCSE and do well, but at the A level, it may be much harder, you may not achieve as good of a mark. Yep, I completely agree with you. So chemistry is a lot harder at A level than GCSE in my opinion, but I really enjoyed it at GCSE, so I did it at A level. I firmly believe that if you enjoy something at A level, you'll work a lot harder. And it's not, everyone always says it's the hardest science to do. I don't think it is. I think as long as you put effort in, you'll be absolutely fine. And your teachers will always help you, and there's loads of online resources now as well. So any idea then, what are the formulae for these two monomers? It's quite a tricky question, so don't worry if not, we'll go through it together. Okay, so no one's given me an answer to that. So let's go through it together then. So first of all, let's start with the carboxylic acid. So hopefully you'll remember when we join a carboxylic acid and an amide together, we get this peptide bond. And we need to know the two monomers. So the dicarboxylic acid is over here, and all that's missing from it is the OH bond. So if we want to draw out this dicarboxylic acid, all we need to do is do our COOH on one end. So that's our carboxylic acid on one end. The CH28, so I'll write that in, CH28, that's just the middle part. And then the carboxylic acid bond on the other end, and that's it. So all we had to add were the OHs, because remember, they're lost when we join up with amides, and that's what happens in condensation polymerization. The water molecule is lost. Good. So someone did give me the correct answer there, so well done. Okay, now that you've seen what I did for that monomer, what do we think happens for the second monomer then? What's missing in that second monomer? So the amide. So pretty much everything's there. One thing is missing. What do we think? Do you have any tips on how to remember information? Yep, so the tip I've been giving throughout is to use Post-it notes. So that's what I did. Whenever there was some tricky concept that I didn't understand, an equation that I couldn't quite remember, I would write it on a sticky note and I would stick it up on my mirror, in my bathroom, or in my room, just so I could see it every morning when I woke up, and that helped me. I think mind maps are also really useful. They can help to summarize a topic really well. It just depends though, because sometimes they can be a bit too basic and then you lose kind of some of the other aspects that you need to know. So when I was doing my GCSEs and A-levels, I found writing notes and reading a lot easier. And yes, I do really look at the Post-it notes in the morning because they're there around you. So good. Okay, so someone has given me an answer to the second question, and you are exactly correct. So NH2, CH28, NH2. Exactly. So what's missing here is another another hydrogen. So it would be NH2, which I'll just write like this just for now on one end. We've then got our CH2, I think it's 6 there actually. So CH2, 6, and then NH2, like so. So that's what's missing, just one hydrogen from each end, and that's what makes it the amide. Do you like revision cards, or do you believe you forget? I don't like revision cards. I prefer kind of notes on topics, but that's just me. Will there be lessons next week? Yep, there will be. So Monday is bank holiday, so there are no lessons on Monday, but there are lessons Tuesday, Wednesday, Thursday and Friday. For chemistry, we've got lessons on Wednesday and Thursday next week. Okay, great. So the last question that we'll do then before we go on to electrolysis. So polymers can be made from alkenes. Which of the following statements about alkenes is correct? So do alkenes turn bromine water orange? Do alkenes have a double bond between two hydrogen atoms? Are they unsaturated? And can they undergo complete combustion to produce carbon monoxide? What do we think? A, B, C, or D? Someone's saying it's not easy reading notes from a book and you're likely to forget. I completely agree. So I'm a bit of an auditory learner. So when I read my notes from my book, I read them out loud because when I'm reading them, then I'm using my eyes to look at the notes and my ears also listening. So I'm more of an auditory learner. So it just depends kind of what you prefer, and that's worked for me throughout most of my GCSEs and A-levels and also at university. Good, yep, C. So remember, alkenes turn bromine water colourless, so from brown to colourless, not orange. They do have a double bond, but between the carbon atoms, not the hydrogen atoms. They are unsaturated, so that basically means that there could be more hydrogens in there, but because of the double bond, there isn't. So this is the answer. And they do not undergo complete combustion. They undergo incomplete combustion to produce carbon monoxide and water. Okay, so what is the name of this polymer then? Here, does anyone remember what's the name of that polymer? So that's the simplest polymer that we've learnt about. So lots of questions about revising for exams. So how long did you revise for your exams? I think it's a subjective thing. So some people need more revision than others. I used to just have a really good schedule. So I'd wake up in the morning quite early and I'd revise until kind of about 6, 7 p.m. in the evening because I'm not very good at revising after that time. So I think it's just about figuring out what works well for you timing wise and then trying to do it in little chunks. So I used to do 40-minute I used to do 40 minutes of revision, then a 10-minute break, then 40 minutes of revision kind of throughout the day. So especially when we were getting closer to the exam. Good, so it's called polyethene. So well done everyone that gave me the answer. And as I said, you can write that as polyethene, you can write that as polythene or polyethene with brackets. All three of those answers would be absolutely fine. Okay. We need to draw polypropene then. So they've given you a nice example as well. What do you think? How do we draw that? So someone's asking about lessons next week. I've just answered that. I said, yep, there are lessons next week, just not on Monday because it's bank holiday. How long should you revise in a day? Again, it's subjective, but I revised however much I could do, if that makes sense. But don't overdo it because you'll burn out. And did you do your schedule 2 years in advance? No. I did it a couple of months before the exams. Okay, so how do we draw that polymer? How do we draw polypropene? Any ideas? Good, break the double bond and put a line through them. Excellent, well done. So first of all, we need to break the double bond. So put a CC there. We've got then just got to copy what's over here. So literally just copy it with your broken double bond and then lines like that to show the continuation. Square brackets, making sure your line goes through and an N. And that would give you all the marks. Excellent, well done everyone. Hopefully you now feel a little bit more comfortable answering exam questions. As I said, with the natural polymers, there aren't that many questions on them, and the questions we were doing were actually an old exam board because most of the new exam boards don't have any exam questions. To the person asking, I'm studying medicine at university. Which subjects do you need for medicine and do you need experience in hospitals? So you usually need 2 sciences, so either biology and chemistry or chemistry and physics. Usually they always want chemistry, but they want 2 sciences. And I think maths counts as a science as well. And you need to do at least 3 A-levels. I would recommend doing some experience, not actually for your UCAS form, which is the form you do for university, but just because it will help you to decide whether it's actually the degree you want to do. So working in a hospital is a lot harder than you think it is. Okay, so let's move on to electrolysis, today's topic. So electrolysis is basically breaking down an ionic compound. So remember, what are ionic substances made of, first of all? Does anyone remember from quite a long time ago now, what are ionic substances made of? Good, a metal and a non-metal. So that's the really important thing that I want everyone to remember. Ionic compounds are made of metals and non-metals. So remember, that's kind of the purpose of ionic compounds. The metal forms a positive ion, the non-metal forms a negative ion, and they come together and form an ionic bond. Okay, so we can break these ionic substances down by passing an electric current through them. But you may remember that ionic compounds form these giant lattices that are in structures, kind of regular layers like so. Remember, some will be positive, negative, like so, and there'll be an equal number as well. So I won't continue drawing that, but remember they're in those regular lattices, which means it's really difficult for those ions to flow. So if we want to pass electricity through it, we need to basically melt it, either melt it or make it into a solution. So the 2 ways that electrolysis occurs is that we can melt this compound, make it a molten compound, or we can dissolve it in a solution, making it aqueous, and that will allow these ions to almost break apart from their structure and to flow. So for electrolysis to work, the compound must contain ions, and the ions must be able to move. And so that's only possible when it's dissolved in a solution or it's melted. It also says here that covalent compounds cannot act as electrolytes because they contain no charged atoms. So remember, for something to carry a charge, it has to be, to carry a current, it has to be charged in some way. And covalent compounds aren't, they're neutral because they're sharing electrons, so the total number of electrons hasn't changed. Okay, any questions on that? No? Okay, great. So let's move on then. So this is kind of the circuitry used for electrical circuits in electrolysis. So let's try and label all the parts. So where I've drawn all the red arrows, we need to try and label the parts. So first of all then, what do we think this is? So if you do physics, hopefully you recognize this symbol. What do we think that is? Good, yep, a cell or a battery. Yep, a cell or a battery. So that's just gonna provide the power. Okay. We don't need to distinguish between these yet, but what do you think they are, these two rods here? What could they be? One's positive, one's negative. What could they be? Excellent, they are electrodes. They are electrodes, really good. Okay, and which one's the anode then, and which one's the cathode? So everyone's saying anode and cathode. Which one's the anode, which one's the cathode? Excellent, yes, anode is positive and cathode is negative. Great, well done everyone. So anode is positive and cathode is negative. Now, I'm just going to pause there to explain something. So you may remember when we have our metals, let's take potassium, for example, which is K, that's its symbol. When it forms an ion, it loses one electron. It loses one electron to form K+. So it has one more proton than electron. And that's because it's in group 1, so it has one electron in its outer shell. So to gain its full outer shell, it loses one electron. We name this a positive ion, also known as a cation. So it's really important you don't get confused between a cation being positive, but a cathode being negative. And I'm going to show you how I remember it in just a second. So potassium ions form positive ions that are called cations, but the electrode that is called a cathode is negatively charged. And the electrode that is positive is called the anode. But remember, for example, chlorine is an anion. Okay, what about the last arrow then? What's this? And it's not water. Someone's asked me, did you achieve the grades you wanted? Also, do you believe your hard work paid off? Yeah, I did. I was very happy with both my grades at GCSE and A-levels. And yeah, I do. I think my hard work did pay off. Obviously, there are going to be times where things are out of your control. But as long as you work hard, I think you'll be able to achieve the grades that you want. Someone's asking me how I revised for Latin. That's a really good question. It was a difficult subject to revise for, and because I wasn't really doing any essay-based topics apart from Latin, I struggled a lot. It was probably one of my harder A-levels, but perseverance was one of the main things, and my teacher was absolutely excellent. She gave me loads of extra work to do, which helped me to bring my grade up. What made you want to pick Latin? I really enjoyed Latin at GCSE. It was my best subject at GCSE as well, and I really enjoyed it, but it was a huge step up to A-level. Someone's asked me how old I am. I'm 22. Okay. Right. Last, what's this one then? What's this last arrow? So it's not water. What do we think? What's this last arrow? Good, it's the electrolyte. Excellent, electrolyte. So electrolyte just means either molten or in a solution, your ionic compound. That is the electrolyte. Excellent, well done everyone. Okay, any questions on the equipment that we use then? So I'm going to explain it in just a second, but essentially we apply some type of power. We have a cathode and anode that are usually made from non-reactive substances. And the reason for that is that when we have our electrode in there, our electrolyte in there, we don't want it to react with the electrodes. So for example, carbon is quite unreactive. So if our electrolyte is something like lead bromide, it won't react with the carbon, and that's what we want. So we want unreactive graphite, carbon, things like that to make the electrodes. How many years am I studying medicine for? It's a 6-year course. I'm about to go into my 5th year. Okay, so just a bit about the electrolysis equipment then. So to be an electrolyte, a substance must be able to conduct electricity, which we've already covered. We can actually test for conductivity, which you may have covered in your physics sessions. And so we include a sample of the substance in a circuit that contains a source of current and an ammeter. What does an ammeter do? Does anyone know from their physics sessions? I know you've definitely covered circuitry. So what does an ammeter do? Good, it measures current. Yep, so that's why we have it in there. So we include a sample of the substance in a circuit that contains a source of a current and an ammeter which measures that current. And if a current flows through the substance when it is molten or dissolved, it is an electrolyte. So we need that current to flow through. The electrodes are often made of an unreactive substance, which is what I mentioned. So graphite's the usual one. And as I said, that's so the electrolyte doesn't react with the electrodes because that's not what we want. And then this final point here is how I remember which electrode is positive and which electrode is negative. So as I gave my example before, we had potassium ions and we said they are cations. Now what happens in electrolysis is that these potassium ions will go to one of the electrodes and essentially it will gain an electron to become potassium or the element potassium, so it will be neutral. So for it to gain an electron, it needs to go to the negative electrode or the electrode with electrons. So the negative electrode is the cathode. This is the negative electrode. So these potassium ions, which are positively charged, get attracted to the negatively charged cathode. They gain an electron and become potassium. So the way I remember it is the cations are attracted to the cathode. And the same thing happens with the anions. So anions, let's imagine we've got chloride. Chloride forms a negative ion and it wants to lose an electron to form chlorine, which goes around as pairs, but just chlorine as an element. So to do that, it's attracted to the positive electrode, which is the anode. And when it's attracted to that electrode, it gains an electron to form chlorine. So the anions are attracted to the anode. And that's how I remember it. Any questions on that? Because that's a really important point for understanding how electrolysis works. So it's really important that we understand that the positive ions go to the cathode and they gain an electron, and the negative ions go to the anode and they lose an electron. Okay, no questions, that's great. So electrolysis of molten compounds. So remember I said that we could, with compounds, ionic compounds, we can either melt them to make them form molten compounds, or we can dissolve them in a solution to cause them to be aqueous. Now something happens different in both of the molten and aqueous compounds, and we need to know the differences between them. By far, the easiest ones are molten compounds. And the reason for that is it is as simple as the metal ions going to the cathode, which is what we'd expect because metal ions form positive ions. And they usually form a neutral element, which is what I said, and that could be a solid or a sludge metal. And the non-metal ions going to the anode, and usually they form bubbles of gas. So when we have molten compounds, your ionic compound will usually be broken up into its metal and non-metal. The metal will go to the cathode and it will gain an electron. The non-metal will go to the anode and it will lose an electron. So when we do electrolysis of molten compounds, it's really easy to predict what will be formed at each electrode. How come your previous webinars weren't on YouTube? So when I checked yesterday, all of them were up, even yesterday's one from this week, they're all up. What happened was on Monday, we had tech problems, so we didn't actually have a webinar on Monday. And that's why today was actually supposed to be our second electrolysis session, but it's our first because Monday's webinar didn't occur. Someone's asking me, will you still continue private tuition after you complete your degree? I'm not sure yet, depends how busy I am. Okay, any questions about electrolyzing molten compounds? So I've got an example here, which is lead bromide. So lead is Pb, 2+, bromide, Br-. And when made molten, so that just means heated, we use a lot of energy to heat them up, make them molten. It breaks down into lead ions and bromide ions. The lead ions will be attracted to the cathode, which is what I said, because the cathode is negatively charged. And at the cathode, they will form lead, and usually that forms a silvery liquid metal. In exam questions, they wouldn't expect you to know what state the metal will be formed. It's just important that you know what's formed at each electrode. And then bromine. So the bromide ions will go to the anode, and there they will become bromine. So they will lose an electron to become bromine. And they usually form bubbles of brown gas, so a vapor is formed. Okay, any questions on that? The reason there's a 2 under bromine is because bromine tends to go around as in pairs. So remember, all the halogens tend to go around in pairs. Do the cathode and anode need to be replaced regularly because graphite reacts with oxygen? Yep, it does. And we're going to go over that next week when we look at the electrolysis of aluminium. Yep, so I've not covered that today because we'll look at that in more detail next week. So today we're just covering the basics of electrolysis, but really good point. Yes, bromine is diatomic because usually it goes around as pairs. Yeah, good. Did you have tuition before your exams? No, I didn't. My teachers were very good at my school and they gave me the help I needed when I needed it. Okay, so questions then. What is produced at the anode and cathode in the electrolysis of molten zinc chloride? So what's produced at the anode and cathode in molten zinc chloride? What do we think? Good. The anode will produce chlorine, usually as a gas, excellent, and the cathode will produce zinc. Really good, well done everyone. So cathode, zinc, and anode, chlorine. And remember, that's because the positive ions, the zinc ions, which will be Zn2+, will go to the cathode to become zinc, whereas the chlorine ions are negatively charged and they will go to the anode to produce chlorine gas. So if we were balancing out, it would look like that. Good, we will go over half equations, hopefully today. If not today, then tomorrow. An anode is a positively charged electrode. So if I just go back to this slide here, remember the anode is a positively charged electrode and the cathode is negatively charged. Okay, the second question, what is produced at the anode and cathode in the electrolysis of molten aluminium oxide? Molten aluminium oxide, what's produced at the anode and cathode? Good, yeah. So anode is oxygen, cathode is aluminium. And again, that's because aluminium forms an Al3+ ion, so it's attracted to the cathode, which is negatively charged, so it forms aluminium. And oxygen forms an O2-, and it will be attracted to the anode to produce oxygen, which again goes around in pairs. So cathode will be aluminium, anode will be oxygen. Someone's saying, how do you know what the anode is? So I'm not sure what you mean by that question, but in exam questions, they would usually just ask you what charge the anode has. So the anode will be positively charged, and it's usually made out of a non-reactive substance such as graphite. So that's all you need to know. Good, okay. All right, sorry that's been cut off. Don't worry about that, I will cover it for us anyway. So this is slightly harder than the electrolysis of aqueous solutions. And the reason this is harder is because there are some rules that we need to remember. But as soon as we understand those rules, it becomes a little bit easier. So we'll start off with what happens with the metals then when we have an aqueous solution. So first of all, aqueous means that we dissolve in water or some kind of solution that has water. And this first point talks about the water itself. So remember, water is H2O, and water will dissociate into hydrogen and hydroxide ions. So hydrogen ions and hydroxide ions. So we tend to dissociate when we have a solution into hydrogen and hydroxide, and that's when we're adding a current through it. So what happens then is, because we've got our hydrogen ions that are positive, and we've got our metal ions that are positive, so for example, let's say we have potassium, they are both competing to go to the cathode. because they're both attracted to the cathode. So essentially, we could form hydrogen at the cathode, or we could form potassium. And what's really important is that we know which is formed, and there's a rule for it. So the rule is that the metal will be produced if it is below hydrogen in the reactivity series. So essentially, if it's copper, silver, or gold, the metal will be produced. If it's more reactive than hydrogen, then hydrogen will be produced. So all of these over here will produce hydrogen. So if we're competing with potassium and hydrogen, hydrogen will be produced, not potassium. And that's because potassium is more reactive. Now, does anyone know why? Why does it matter about the reactivity? Why does it matter? Why is it that hydrogen will be produced if the metal is more reactive? It's not a displacement, because remember, actually, potassium would displace hydrogen because potassium is more reactive. Is there a way you remember that list like a rhyme or something? I don't think I had a rhyme when I was remembering it. I'm not sure. I think it actually used to be, what I would do is at the beginning of every exam, we used to get inserts for the periodic table, which I think most of the exam boards still give. And on the back of the periodic table, once the exam had started, I would write the reactivity series down. So it would be something that I always wrote down at the beginning, because you're allowed to write on the periodic table. So maybe you could do something like that, or on the front of the exam paper. Okay, so no one's given me an answer for why hydrogen's produced, which is absolutely fine. It's actually to do with their reactivity. So if we think about potassium, it's really, really reactive. And what that means is it readily forms ions. So it forms the potassium ion really readily. So hopefully you remember that from a couple of weeks ago when we covered the group 1 metals. It likes to lose an electron to form a potassium ion. And what that means is when it gets attracted to the cathode, it doesn't want to gain an electron to form potassium. It's stable as a potassium ion. It's very reactive. It likes to stay as a potassium ion. So essentially the potassium will dissociate to potassium plus and an electron. Whereas hydrogen doesn't really like to lose an electron. It likes to stay as hydrogen itself, as hydrogen gas. So what that means is if the metal is more reactive than hydrogen, hydrogen will be produced because it's happy to gain an electron and form hydrogen, whereas potassium isn't as happy to gain an electron. It likes to stay as an ion. Any questions on that at all? So that's how you explain it. You wouldn't be asked to explain it in an exam. It's just to help you understand why hydrogen is produced if the metals are more reactive, whereas if it's less reactive, then the metal will be produced. Yeah, we're going to go on to the anode. This is just about the cathode at the moment, but good question there. So we will go on to that. Okay, good. So no questions on that. So at the anode then, this is a little bit more tricky to understand. If the negative ion is simple, which basically means if it's a halide ion, then the halide will be produced. So if we have chloride ions or iodide ions on there, we will form chlorine or iodine. If the negative ion is complex, something like nitrate, sulfate, then oxygen gas will be produced at the anode. And so we get oxidation of the hydroxide ions. So essentially, remember I said that water splits up into hydrogen and hydroxide. This hydroxide ion will lose an electron to form oxygen gas. So that's what happens when the hydroxide ions become oxidized at the anode. So for example here then, aqueous copper chloride will form copper at the cathode. And the reason for that is copper is below hydrogen in the reactivity series. So it will form copper at the cathode and chlorine gas at the anode. And that's because chlorine is a halide. So there's one point there to remember though, and that is this word here, concentrated. If you have a dilute, so a dilute halide, then oxygen will be produced. So the general rule is that oxygen will be produced unless you have a concentrated halide, and that's what I would remember. So it doesn't matter what you have, oxygen will be produced unless it's a concentrated halide, and that's what most of the exam boards tend to kind of write down as a rule in their textbooks. It must be concentrated. So if something says it's dilute, that means oxygen will be produced. It has to be concentrated. And again, the reasons for this is to do with the reactivity. So for example, a nitrate ion is quite stable. It likes to stay as a nitrate ion, and that's why instead oxygen gas will be produced, because the nitrate ion does not want to lose its electron. It likes to stay like that, whereas oxygen doesn't, so the hydroxide ion, sorry, is quite happy to lose its electron if it needs to produce oxygen gas. So it's to do with the kind of the willingness of these elements or compounds to lose electrons at the anode. Okay, great. So a few questions then. What is produced at the electrodes during the electrolysis of aqueous copper sulfate? So copper sulfate, so first of all, cathode. What's produced at the cathode when we do aqueous copper sulfate? What do we think? Good, copper, and that's because it's less reactive than hydrogen. Excellent, well done, so copper. Okay, what about the anode? What's produced at the anode? So sulfate, I'll tell you, is a complex ion, and we know that. Good, so it's not going to produce sulfur, it's going to produce oxygen. We will do Mentimeter soon, so oxygen, yeah, excellent, well done. What is produced at the electrodes during the electrolysis of aqueous sodium chloride? So aqueous sodium chloride. So what's happening at the cathode, first of all? This is the first one. So second one, what's produced at the cathode? Okay, some people are saying hydrogen, some people are saying sodium. They do compete, yep. So remember the rule, it's hydrogen, excellent. And the reason it's hydrogen is because sodium is more reactive. So sodium will not be produced, ooh, hydrogen will be. Okay, what about the anode? What's going to be produced at the anode? So we've got chloride ions there. What's going to be produced at the anode? It's not saying it's dilute, so yep, we can assume chlorine. Good, well done. So chlorine gas usually, but again, you don't need to know the state. Chlorine, excellent. Any questions on those two? I will go back to the previous slide in just a second. Okay, what is produced at the electrodes during the electrolysis of aqueous sulfuric acid? So slightly more difficult. What's the compound or the formula for sulfuric acid? Anyone remember? So I think we covered this a couple of weeks ago when we did neutralization. It's not SO4. What's the formula for sulfuric acid? H2SO4, H2SO4, excellent. So that means it will split up into its ions of H plus and SO4 2 minus. So what will be produced then at the cathode? Hydrogen, and it has to be hydrogen because we've got hydrogen ions in the sulfuric acid and hydrogen ions from the water, so it must be hydrogen. Yeah, good. So hydrogen in sulfuric acid, so cathode produces hydrogen. Good, what about the anode? We've got sulfate ions in there. What do we think? Oxygen, excellent, well done. Good, okay. Someone asked me to go back to the previous slide. So this is about the anodes and what's produced at the anode. So the general rule is a concentrated halide will be produced unless we've got a complex ion in there or unless it's dilute, and then we produce oxygen. Really good answers to the questions there, everyone, so well done. Now just going to quickly recap what we've covered with regards to molten versus aqueous electrolytes. So let me go back to the slide. Okay, so understand and explain the difference between the products produced at each electrode in an aqueous versus molten electrolyte. So let's start with molten. So with our molten electrolytes, at the cathode, we get our metal, and at the anode, we get our non-metal. So nice and simple with those ones, it's just splitting it into metal and non-metal. What's more tricky though is the aqueous solutions. So with aqueous electrolytes, at the cathode, we will either produce hydrogen or the metal. And what's really important is how reactive that metal is. So if the metal is more reactive than hydrogen, we produce hydrogen. If the metal is less reactive than hydrogen, we produce the metal. So what I'll do is I'll put, say, metal, more reactive than hydrogen, then we produce hydrogen. If the metal is less reactive than hydrogen, then we produce the metal. So that's the general rule for the cathode. The general rule for the anode, we can either produce a halide or oxygen. And the general rule is halide is produced if it's concentrated, if not oxygen, basically. If not oxygen. So if you've got a halide there and it's concentrated, we produce the halide. If it's not the halide, we're going to produce oxygen. So that's the general rule. Any questions on that there? How do you know if it's concentrated? You know if it's concentrated because I'll tell you in the exam question if it's not. So just look out for something that says dilute, basically. If it says dilute, then you know it's not, but if it doesn't, then it's fine. So someone's just asking me, what does Y mean? I'm not sure what you mean. What Y? No? Okay, that person's just asked me. Please, can you go back to the previous slide? Yep, I can. Was that the question slide or the slide on the anions? Yeah, we are going to do the quiz in just a second. Slide 2. Yeah, that was slide 2. There you go. So this was just about electrolysis itself and what goes on. You're welcome for the person saying thank you. What are the properties of giant ionic lattices? I've not got time to explain those today. If you go back to probably one of my first webinars with you guys, there's a really good session that we did on ionic compounds, and it goes into it in a lot of detail. All the compounds, so metallic, covalent, and ionic, we go into there. Okay, let's do a quiz then. The last question on the quiz, you'll have to guess because it's about half equations, so you might not be able to do it yet, and we haven't had time to cover it. Once we've done the quiz, we'll have a brief look at half equations, but I think let's do the quiz first. Okay, so if you go to menti.com and type in 62 73 25, you should be able to do that. So menti.com, that's all you need to go to, and then type in 62 73 25. Good, I can see lots of you. There's lots of you in the webinar today, so hopefully we'll get lots of people joining. And as usual, I think the quicker you answer the questions, the more points you get. The first 4 questions you should be able to do. The final question, I don't think you'll be able to do because it's a half equation, but again, just take a random guess. Okay, so I've got 12 of you so far, so I'll just wait a bit more time because there's quite a few of you in the webinar today. Someone wants me to go back to slide 4. I will do that after the quiz. All right, I'll do that after the quiz. And as usual, any questions we're going along in the quiz, pop them into the Q&A or the chat box function, but I'll try and explain the questions as we're going along and all the relevant answers as well. So I've got 14 of you in the Menti quiz at the moment. I'll wait another minute. And I think if you've not joined yet, you can still join halfway through. But I would recommend joining at the beginning if you want to appear on the leaderboard. So I think we've had a different winner every day so far, so that's really good. Not just got one winner. Okay. I'll wait another couple of seconds then. So I've got 16 of you in there. There's quite a few of you that haven't joined the Menti quiz. So if you want to do the quiz, you can still just send me the answers on the Q&A or the chat box, depending on what you prefer. Okay, let's start it off then. Now, as I said, you can join as we're going along. All right, so I'm starting it. So first question should be coming up on the screen. What is the negative electrode known as? So the negative electrode, you have to type the answer in. So there's really only 2 answers. So what's the negative electrode known as? And when I say 2 answers, you've got a 50-50 option, basically. It's either going to be one or the other. Okay, 5 seconds left. Make sure you've spelt it correctly. Good, the answer is cathode. So remember, the cations are positive. They go to the negative electrode, which is the cathode. Excellent, well done. For someone misspelt it, but that's fine. It's not the anode. Anode is positively charged. Excellent, well done, everyone. Okay, the second question should be coming up in just a second. Which of these would travel to the anode during electrolysis? Which of these would travel to the anode during electrolysis? So it doesn't matter here whether it's molten or aqueous, because only one of them would ever travel to the anode during electrolysis. So 3 seconds left. The answer is chlorine. Excellent. So lead is positively charged. Remember, positively charged ions, it's Pb2 plus, go to the cathode. Sodium is Na plus, that goes to the cathode. Chlorine is right, it forms Cl minus, so it will go to the anode. It will be attracted to the positively charged electrode, which is the anode. And hydrogen forms H plus, so it's attracted to the cathode where it gains an electron. Well done. Okay, next question should be coming up now. So what's formed at the cathode during electrolysis of molten potassium iodide? So the keyword is molten potassium iodide at the cathode. At the cathode, what's produced? Is it iodine, potassium, oxygen, or hydrogen? So it's molten. Good. The answer is potassium. Well done. So, and remember, that's because potassium ions are positively charged. They go towards the cathode. So they go towards the cathode. So because it's molten, we form the metal at the cathode and the non-metal at the anode. So iodine would be produced at the anode. Oxygen and hydrogen are not involved because it's not aqueous. If it was aqueous, then hydrogen and oxygen would be involved. But when it's molten, we're only melting potassium iodide, so there's no water in there. But when it's dissolved in the solution, we produce oxygen and hydrogen. Excellent, well done. The next question should be coming up now. What is formed at the anode during the electrolysis of aqueous dilute potassium iodide? 2 key words: aqueous, dilute. Aqueous, dilute. That's all I'm going to say. That's your clue. Aqueous and dilute. So what's formed at the anode during the electrolysis of aqueous dilute potassium iodide? 3 seconds. And the answer, which is oxygen, which most of you didn't get. So the reason for that is because potassium will go towards the cathode, but because it's more reactive than hydrogen, hydrogen's produced at the cathode. Remember, hydrogen's attracted to the cathode. This asked about the anode. So the anode, the only things that could be produced are iodine and oxygen. The reason it's not iodine is because of this keyword here, dilute. So that's why I emphasize dilute and aqueous. So it's oxygen, and that's only because it's dilute. Otherwise, iodine would have been produced. Okay, so the next question you can all have a guess at. It's about half equations that we haven't managed to cover today. So which of the half equations below is correct for the oxidation of hydroxide ions? Again, have a guess because we've not managed to cover it. So you've got a 25% chance of being right, but we will cover it hopefully next session. Okay, 3 seconds. Good. So the answer, which I think 5 of you actually got, which is great, was this one here. And to explain that, we've got 4 hydroxide ions. When it dissociates, or when it goes to the anode, it forms water and oxygen. So we knew it produced oxygen because I told you about that. But what's also happening is it's losing 4 electrons. So you can either write that as plus 4 electrons on the product side or loss of 4 electrons on the reactant side. Probably a bit confusing at the moment. We will go through it in a lot more detail next week. Great, so let's have a look at the leaderboard. Excellent, well done. So I think this person's the winner. Yep, well done. And thank you everyone for joining the quiz. Hopefully you enjoyed it. Okay, so someone asked me to go to slide 4. So this is slide 4. And the main point on this slide was about positive ions, so metal ions usually going towards the cathode, doesn't have to be metal though, it can be hydrogen, going towards the cathode, and negative ions going towards the anode. So I don't think we've got enough time to go through half equations today because it's quite a tricky topic and it is higher tier as well. So what we'll do is we'll finish off there today. Thank you everyone for joining me. I hope you enjoyed the session. We've covered the main two learning objectives, but we will do half equations next week, I promise. And we will also do lots of exam questions. So thank you everyone for participating and answering all my questions. Have a lovely weekend and bank holiday as well. And I'll see you next Wednesday at 9:45 for the second session on electrolysis. All right, take care everyone. Bye.